Hello everybody. Today we're going to study new chapter. We still focus on DC circuit analysis, but now we have combined resistor with capacitor or resistor with inductor circuit. We want to do the DC circuit analysis of RC and RL circuit. First, source function. A voltage source, DC voltage source, is a straight line, constant straight line, either positive or negative. This is positive voltage, this is negative voltage. Okay? First is what? We study what? First we will study how step source function, rectangular pulse, ramp, triangular pulse, and impulse are example of function. First, step function. Step voltage source function. Voltage can be step function. Step function means that, you see here, the symbol is UT. When you see the symbol in signal and system, it's symbol UT, you will consider it to be a step function. Step function means that at negative time, this one, negative time, is a zero, always zero. Negative time, always zero. Then positive time, always one. So in the purple color here is so at negative time is zero. Then at positive time is step to one. This is called step function, step voltage function. Symbol is what? UT. Then if for what? If we introduce the step function with a delay, positive delay, if you shift the positive delay with T0, it will shift right hand side T0. This called time delay. If time advance means that when T0 negative time, it will shift to left hand side, means that it's advanced. In earlier happen earlier, advance. You know, it's a voltage T0. It's T0. Negative is for positive is this side. If negative is this side. So if with time V0, step function unit is what? Unit is 1. If with time with V0 time equal to V0. So 1 times V0. So is magnitude is what? V0. A rectangular pulse can be formed by two step functions. T1 here, T2 here. This is the rectangular pulse formed by two what? Step function. Then ramp function. Ramp function is what? Ramp function symbol RT. When negative time is 0. Negative time is 0. Negative time is still 0. Positive time, it ramp out. With 1 equal to 1. 1 when t equal to 1 is equal to 1. When t equal to 2 is equal to 2. Same is if this one is a delay with T0. So shift this one to T0. Shift this one holding to T0. If delay T0 is shift holding to T0. From step, if you integrate step function here, if you integrate step function, you will get what? Ramp. Integrate ramp function, integrate step function, you get ramp function. If you integrate, if you differentiate step function, you get delta function. Impulse function, not delta. Impulse function or called delta function. You know, you differentiate step function, you got impulse. This is impulse function. 0, it happen magnitude almost equal to 1. If you delay T0, if you minus T0, it will shift to right hand side T0. Okay? Now, until now, we study is a call short. Every circuit we study, we have a source. Now we have to call form a circuit that has called source-free RC circuit. Source-free means no source. Source-free, no source. Like this one. Capacitor is what? It's fully charged. Fully charged already. Then we connect this to a resistor. It will do what? Discharging. The voltage V, this voltage what? Capacitor is fully charged. Fully charged. Then we connect to a resistor. So capacitor will discharge to resistor. Discharging. So the voltage here V is given by what? V equal to V naught. V equal to V naught E exponent minus T over RC. This same as discharging formula. So this solution is called natural response of the circuit. The natural response of the circuit refers to the voltage or current of the circuit itself with no external source excitation. Since this had no external source, it only due to capacitor voltage only, capacitor. So this is called natural response. The value of RC, this R and C product is also called time constant. Next, source-free RLC, RL circuit. Same. Inductor, store magnetic field, then fully store, then it connect to a resistor. Then it will discharge. So it's current I, this I current, this I current is equal to I naught as well E minus R over LT. Minus R over LT. R and LT. Where L over R is termed the time constant of RL circuit. For capacitor, for RC circuit, the time constant is R times C. R times C. For inductor RL circuit, the time constant is L over R. This is RL source-free circuit. RL source-free circuit. Next, we study step response of RC circuit. Step response. So that means that what? Negative time is 0, positive time is 1. If we start time be source voltage Vs, so the magnitude become Vs. This source voltage, negative time 0, positive time is Ut. Is Ut 1, but time is Vs, so it become Vs. So same as you negative time you open the switch, positive time you close the switch, it's step response, charge the capacitor. So capacitor IC current will be IC equal to C dVc dt. Vc is capacitor voltage, C is capacitor value, C dVc dt. This is capacitor current, this current. Okay? Then the Vc will be equal to this equation. Okay, this equation. This capacitor voltage charging is equal to Vc. This equation as done to previous chapter. So refer to section 5.41. That's considered in a case where step function got a what? Got an initial what? Initial voltage. V naught plus Vs minus V naught Vt. Okay? Initial voltage plus initial voltage V naught. So this V naught we also form, it can form what? It form a complete response, it form a natural response, and a forced response. Forced response is due to what? Then the complete response of RC is to a sudden application of DC voltage. So is what? Complete response equal to natural response plus forced response. Complete response is Vn natural response plus forced response. Natural response is what? V naught exponent minus T over RC is source free. Then forced response is what? Vs 1 minus E minus T RC. This one is the force external source from this source. From this source. It's called from this source. This source. This source is called the what? The force response. Okay. The natural response here is what? Is the what? Is the source free. Or you can say that, and put in other words, is complete response equals to transient response per steady state. Transient means charging is this one, V0 over Vs, tau over Rc. Then steady state is Vs, stable. So example 6.1 we will cover in full lecture. When you study full lecture, we'll cover. Next step response of RL circuit. Step response. We put the initial condition here. Then put a step response. Step response 1 times this one magnitude. Then initial voltage. Then put to inductor L, current IL to that. Then voltage VL. Now the VL, the IL here, this IL is given by IS minus IL T over L. The voltage inductor VL, then this VL is given by L di dt is this one differentiate with respect to dt, that times L, you get this one. Okay. Then we go to tutorial 6. After finish this one, we will go to tutorial 6. And then we will cover tutorial 6 in tutorial session. Thank you for listening.